All right, so the question is 8.4 grams of magnesium was completely burnt in oxygen and the product weighed 14 grams. Find the empirical formula of the product. So you can see in this question we have magnesium and oxygen reacting to form an oxide of magnesium. So if you're to calculate the empirical formula, then you're going to follow the following steps. Firstly, we start off with the element. Now the question is, what elements will be present in this compound? And that would be magnesium and oxygen. So you'll put magnesium right here and put a space it and put oxygen the other side. The next thing that you look at now is the mass. The mass of each of these elements. From the question, you have 8.4 grams of magnesium. That means the mass of magnesium in that product must be 8.4. The next thing is to find out the mass of oxygen. If the product weighed 14 grams, then the mass of oxygen must be 14 minus 8.4. So this gives us 5.6 grams. So the next step, after you've gotten the elements and the mass of these elements, is to go ahead and get the relative atomic mass. Now the relative atomic mass of magnesium and the relative atomic mass of oxygen are the numbers given in brackets right here. In case you don't have these numbers, then you can usually look in the periodic table and you can find the relative atomic mass. So here is 24 and here it is 16. So the next thing is what I like, my favorite, the mole. So when you get to the mole, there is a simple formula that I gave you in a previous video. Be sure to check that one out, that the mole is given by mass in grams, of course, divided by the relative atomic mass. So mass over RAM. So whatever we have here is the mass and the RAM, so we divide. So that is going to be 8.4 divide 24. Well, if you calculate this, it gives you 0.35. So we have 0.35 moles of magnesium oxide. The next thing is to look for the moles of oxygen atoms. So here again, the mass of oxygen is 5.6 and the relative atomic mass is 16. So when you divide this, you end up with a 0.35. So the next step after this is to calculate the mole ratio. Now the mole ratio is usually given by dividing these moles that you've gotten by the smallest one. So here I'll just note it down, divide by the smallest mole value. So between 0.35 and 0.35, well, there is no smallest one here, so we'll just divide it by itself. So here it's going to be a 0.35 divide 0.35. This gives us a 1. And same thing will happen on this other side. So what this means is that one atom of magnesium combines with one atom of oxygen to form this product. So the empirical formula of the product is going to be MgO. So that is the empirical formula of the product. All right, so that was an easy one. Let's get to another one as well. This is also going to be very easy. So the percentage composition by mass of an oxide of iron is 70% iron and 30% oxygen. Find the empirical formula. Now, from our previous example, you will notice that we need the mass of iron and the mass of oxygen to get to calculate the empirical formula of this compound. But in this question, we have been given the percentage composition. Now, if we assume that we had 100 grams of this oxide of iron, then the iron would contain 70 grams iron and 30 grams oxygen. So if you're given percentage composition by mass, we can as well just assume that they are the mass themselves, because if you had 100 grams of it, it will be a 70 and a 30 grams for this case. So let's go straight ahead. The first thing is the elements. So the elements present in this compound are iron and oxygen. Then the next thing again is to calculate the mass. So now here we'll assume that the compound is 100 grams. So 70% of 100 is going to be 70 grams, or the mass, we can say it is 70. And the mass of oxygen is 30. Then the next level is to look for the relative atomic masses of oxygen and iron. So relative atomic mass of iron is given in brackets right here. It is 56. And the relative atomic mass of oxygen is 16. Now, as again, if you have not been given these values, you can look up in the periodic table. So next part is to calculate the mole. And the mole is given by mass divided by relative atomic mass. So the mass that we have here is 70 over 56. So you can see once you calculate that, you end up with 1.25. So the same is done on this side. And you end up with 1.875. So now you can see we have our moles. The next step is to calculate the mole ratios. And the mole ratios is given by dividing by the smallest number. So I've put it there, divide by the smallest mole value. Now I say smallest even though we are comparing two things, because I know in some cases we might have more than 2. So I'll just put it as a bracket statement for the smallest. So you check between these two, the smaller one is 1.25. So we have 1.25 divided by 1.25. So if you divide 1.25 and 1.25, you end up with 1. Then we divide 1.875, divide 1.25. So it is 1.875. So when you calculate this, you end up with 1.5. Now, when you get such a level, we cannot have 1.5 atoms of oxygen, because these are particles. They need to be in whole numbers. So we can only have whole numbers. So to eliminate the decimal, if it is a 0.5, then we will have to multiply by 2. We multiply everything of these mole ratios by 2. So here you'll see, call it combining ratio. Now in this case, you multiply by 2. So you end up with a 1 by 2 is 2. And a 1.5 by 2 is 3. So you see now we have eliminated the decimal. So now the empirical formula for this compound is going to be And as you can see, that is iron 3 oxide. So that is how you calculate empirical formula. If you really learned something today, give this video a thumbs up. And if it's the first time you're watching, make sure you subscribe. There are many videos that you're going to get once you subscribe. Just make sure you don't forget to ring that notification bell. It's going to help you to know when I upload a new video next time.